वालेकुम अस्सलाम। ओके, तो कल ये एग्जाम्पल मैंने होम असाइनमेंट रखी थी बेटा, तो ये आपने करी होगी। ओके, so you must have done this example. Then this example, now we'll switch to this example, that electric field due to the non-uniform solid sector. Beta, okay, moreover I sent this home assignment to you from David J. Griffith. Okay, so do those examples, example number 1 to 8. Okay, 21 to 28. Now here we are, electric field due to the non-uniform solid sector. Okay, so let me show you one example, and then B and C part you will do that yourself. Okay, so we'll be doing that part A. It's like this. There's a first of all, there's a sphere like cylinder is there. Okay, so this is cylinder here, infinite long cylinder like this. This is an infinite long cylinder. Okay, so the charge resides inside in the meat of the cylinder. For example, it's given to us that the radius is equal to r, radius of this that's equal to r, right? So radius of this equal to r, and this rho is given to you, and rho is equal to what? K multiplied by s. Okay, where s is the radial distance. Okay, or K multiplied by r. It's one and the same thing. Either the rho can be written as K multiplied by small r or K multiplied by s. Okay, it's one and the same thing. Okay, so concentrate here. So let's do this example. We are supposed to calculate electrostatic field inside the cylinder and electrostatic field outside the cylinder. Okay, and then we can plot accordingly. We can plot the graph as well. Okay, so concentrate on this. So here we are. So let me show you this example. So A part is that we have to calculate what electrostatic field inside. So I will write down this small r is less than capital R, and what is given to you is that this rho is equal to K multiplied by small r or K multiplied by s. It is one and the same thing, right? Now we have to calculate what electrostatic field both inside as well as outside. Okay, so first of all we'll calculate the electrostatic field inside. Okay, inside implies that here exists a point. For example, here is a point, this point here, point P, which is at a distance of small r from the axis of the cylinder. Okay, at a distance of small r, and obviously the small r is less than capital R. Okay, then what I will do is this: I will imagine a Gaussian cylinder like this. So this is our Gaussian cylinder whose length is equal to L. Its length is equal to L. Okay, and its radius is small r. Okay, then the electrostatic field at this point will be contributed by only the charge that's enclosed by the Gaussian cylinder, enclosed by this cylinder. Fine. Okay, so what I will do is this: I will try to calculate what is the. I will use the Gauss law here. So integration of E dot dA will be equal to Q enclosed by epsilon naught. Q enclosed के बदले हम लिख सकते हैं बेटा integration of rho d like this, rho d top. Okay. Now this will be in turn equal to E multiplied by surface area, lateral surface area of Gaussian cylinder, and that lateral surface area will be equal to 2 pi small r multiplied by L. Okay, it will be equal to 2 pi r multiplied by L. Okay, surface area of this, lateral surface area. That is circumference multiplied by length of the cylinder. That will be in turn equal to 1 by epsilon naught. अब इस रो के बदले क्या लिखेंगे बेटा? That's equal to K multiplied by R. So K is a constant, pull it out. Integration of this will be replaced by R. Okay, then here d tau. By d tau is the volume element. It's the volume element in the cylindrical coordinates, and the volume element in the cylindrical coordinates will be obviously equal to what? That will be equal to, that will be equal to pi r square multiplied by L. Pi r square multiplied by, sorry, wait a second, it will be equal to, rather it will be equal to the volume element here. What is the volume element? The cylindrical. So that's equal to this 2 pi r multiplied, wait a second, not pi r square L, it's actually equal this, it's equal this. The volume element in the cylindrical coordinates is 2 pi r multiplied by L into dr, like this. Okay, this is the volume element, 2 pi r into L into dr. Fine. And the limits of integration here will be from 0 to small r. Why from 0 to small r? Because only this will contribute. So the charge enclosed will be this. Okay, and only this charge will contribute the electrostatic field at the point P. That's why the limits of integration are from 0 to small r. Okay, so here it will be what? It will be here E multiplied by 2 pi r L. Okay, then here this 2 pi r L is going to, okay, so let me write it first apart, 2 pi r L like this. That's here equal to 2 pi multiplied by K divided by epsilon naught. And here what we have is this will be our r square. So r square, integration of r square will be equal to r cube divided by 3. So यहाँ आएगा बेटा r cube divided by 3. Lower limit is 0, that will vanish. Upper limit is r square. Simply it is r cube by 3. Now 2 pi r L is going to cancel with the 2 pi r L. So here we have 2 pi K multiplied by L. Then r square, integration of r square is r cube divided by 3. Now 2 pi r L will cancel with 2 pi r L. So electrostatic field will be in turn equal to this. It will be equal to this. So 2 pi r L is going to cancel with 2 pi r L. So what we are left with is this K multiplied by r square divided by 3 epsilon naught. Okay, K multiplied by r square divided by 3 epsilon naught. Okay, so this is the electrostatic field, right? Now this in turn implies that the electrostatic field is proportional to r square, directly proportional to r square. Okay, so electrostatic field is inside is directly proportional to r square. Why? The reason is this: as you move from the axis to the surface, number one, electric field must be directly proportional or it must increase linearly as the r. But since this rho it is itself function of r, that means the electric field will increase as r square. Okay, great. Ab dhyan rakho beta. So next is that we want to calculate what electrostatic field outside. Okay, so here I will write on B part is that we want to calculate electrostatic field outside. So r is greater than capital R. So outside electrostatic field is always proportional to 1 divided by r. Fine. So r is greater than capital R. So what electrostatic field will be? It will be like this. Again, I will use the Gauss law. So integration of E dot dA, integration of E dot dA will be equal to Q enclosed by epsilon naught. So here it is 1 by epsilon naught integration of rho multiplied by d tau. Fine. Now this will be again equal to E multiplied by 2 pi small r L. Okay, where small r is the radius of the Gaussian cylinder. Okay. Now the Gaussian cylinder will be like this. This time the Gaussian cylinder will be like this. So ये वाला Gaussian cylinder होगा. Okay. So this will be the Gaussian cylinder whose radius is again equal to small r, and the small r is less than it is greater than capital R, because this point of interest lies outside. Okay. Now, but the charge will be enclosed only up to 0 to up to capital R. Okay, from small r equal to 0 to small r equal to capital R. Okay, so this will be here E into 2 by r L. Fine. Then this will be here equal to इस रो के बदले क्या substitute कर देंगे बेटा, k multiplied by r, so that will be equal to k divided by epsilon naught. Then it's integration of r into this. And what is the volume element here? Volume element is again 2 pi r L dr. So here I will write down 2 pi r L dr. Fine. Okay. Then the limits of integration they will be from 0 to capital R, not from 0 to small r, because only up to the surface of the cylinder there is charge, and it is because of that charge that there will be electrostatic field outside. Okay. Now what I will do again is that I will integrate this. Okay. So यहाँ क्या आएगा बेटा? So here it will be E multiplied by 2 by r L will be equal to 2 pi k L divided by epsilon naught. Okay. So that's a constant that will stay as such. Then r square, integration of r square is simply what? That's equal to r cubed divided by 3. Okay, so like this it is. अब यहाँ ध्यान रखो बेटा. So this will be here E multiplied by 2 pi r L. Then here it will be equal to what? This 2 pi and L is a constant. So pull them out. So it will be like this: 2 pi L multiplied by k divided by epsilon naught. Then integration of r square, that's obviously equal to r cubed divided by 3. And the limits of integration are from 0 to capital R. 0 to capital R. Fine. So this will be in turn equal to E multiplied with this 2 pi L will cancel with 2 pi L. So यहाँ क्या बचेगा? R, and here it will be what? It will be equal to K divided by epsilon naught divided by 3 epsilon naught, and here it's R cube. So that means finally it is like this, that this electrostatic field will be equal to K R cube divided by 3 epsilon naught multiplied by small r. So this is the electrostatic field outside, which implies that the electrostatic field outside is proportional 1 divided by r, same as that of line charge. So that means the electrostatic field outside is as if whole charge is concentrated on the axis of the cylinder. Fine. Okay. तो यहाँ मैं आपको एक टेक्निक, एक शॉर्टकट टेक्निक, एक जुगाड़ टेक्निक यहाँ मैं आपको सिखाऊंगा. Okay. So you have a look on that. अच्छी तरह से यहाँ ध्यान रखना. Okay. So it's like this. For example, if we have point charge like this, just suppose that if we have a point charge, ठीक है ना बेटा? So for a point charge, what is the electrostatic field proportional to? Electrostatic field is simply proportional to 1 by r square. For a point. Okay, proportional to 1 by r square. Then if, for example, here we have a hollow sphere, if there is a hollow sphere, then electrostatic field inside will be equal to 0 first of all. Inside will be equal to 0, then small r is less than capital R, and outside again proportional to 1 divided by r square. Outside proportional to 1 divided by r square when small r is greater than capital R. Fine. Okay. The next is this: when if there is, for example, a solid sphere. If there is a solid sphere, then electric field inside is directly proportional to r. Okay, when small r is less than capital R, then outside it is proportional to 1 divided by r square. Again, proportional to 1 divided by r square. ठीक है ना बेटा? So small r is greater than capital R. Great. Okay. Then there can be another thing like this. There is a solid sphere, but the solid sphere is non-uniform. Okay. And for this solid sphere, what is given is this, that the charge density is directly proportional. So it's equal to like this, K multiplied by R, something like this, which implies that the charge density is directly proportional to R. In that very case, electrostatic field inside will not be directly proportional to R, rather it will be directly proportional to R square. Okay? When small r is less than capital R. ठीक है ना बेटा? Number one, it is directly proportional to R when there is uniform. But if it is directly proportional, if the charge density is directly proportional to R, it means that the electrostatic field inside must be proportional to R square. And electric field outside will be always proportional 1 divided by R square. Always proportional 1 divided by R square. And the same way, suppose that there is a solid sphere. There is a solid sphere. whose charge density is inversely proportional to R. So it's like this, inversely proportional to R. In that very case, electrostatic field inside will be proportional to R is to the power 1 minus 1, which is R is power 0, which means that it's independent of R. Okay, which means that it's independent of R. Take beta. But it's independent of R implies that if you will plot E versus R graph, that will be a straight line. So this is true when small r is less than capital R. And electric field outside will be always proportional to 1 divided by R square, whether it is hollow sphere or it is solid sphere or it's uniform or non-uniform, whatever it is. Electrostatic field outside will be always proportional to 1 divided by R square. Okay, so we are done with the spherical charge distribution. Next is this. Next is this. For example, here we have what? We have a line charge. Next is this. If we have a line charge or line charge, electrostatic field is proportional to 1 divided by R. Electrostatic field is proportional to 1 divided by R. For point charge, electric field is proportional to 1 by R square. Or line charge, electric field is proportional to 1 divided by R. Okay. Then next can be like this. It can be a hollow cylinder. At C implies hollow cylinder. If there is a hollow cylinder, electrostatic field inside will be equal to 0 when small r is less than capital R. And outside again it's proportional to 1 divided by R, as if the whole charge is concentrated on the axis of the wire. Okay, outside it behaves like a line charge. Then next is this. There can be a solid cylinder, uniform solid cylinder. In case of uniform solid cylinder, electric field inside is directly proportional to R. Then small r is less than capital R, and outside it is proportional to 1 divided by R. Okay, when small r is greater than capital R, that is outside. Fine. Okay. Then there's one more thing. Okay, so concentrate here. It can be like this as well. For example, here we have this is a hollow cylinder. We are done with it. This is a solid cylinder. Then there's another example like this. There can be a solid cylinder like this. If there's a solid cylinder, and in case of solid cylinder, this rho is directly proportional to R. Then in that very case, electrostatic field inside is proportional to R square. Okay, number one, it's proportional to R when it's uniform. But if it is non-uniform and the rho being proportional to R, then in that very case, electrostatic field will be now proportional to R square, and electrostatic field outside will be always proportional to 1 divided by R. Suppose that they are the solid cylinder. And for the solid cylinder, this rho is proportional. Suppose it's proportional to 1 divided by R. Let's suppose it's proportional to 1 divided by R. Then in that very case, electrostatic field inside will be proportional to R is for 0. Isn't it? It's proportional to R is for 0, and outside will be always proportional to 1 divided by R. Okay, so I'm sure आपको यहाँ तक ये अच्छी तरह से समझ में आया होगा. In the same way, we are yet to do that, but I will write it here that there is one more charge distribution, and that is plane charge distribution, in which the example number 1 is infinite sheet. For example, there's an infinite sheet. Okay, so for infinite sheet, the electrostatic field, you will see it later on. Electrostatic field is proportional R is for 0, which means that it's independent of R. Okay, for infinite sheet. For point charge, electric field is proportional to 1 by R square. Or line charge, electric field is proportional 1 divided by R. Or infinite sheet, electric field is independent of R. It does not depend upon R. So it means that if you plot E versus R graph, it will be a straight line horizontal. Fine. Okay. Then there is one more thing, and that is called as conducting slab. If there is a conducting slab, infinitely large conducting slab. Okay. For conducting slab, obviously the charge will reside inside, only on the surface. Inside the charge will be equal to 0. So that the electrostatic field will be equal to 0 when the small r, when the distance is less than the thickness. Okay, it is less than d. Later on, we'll be doing the examples on this. Okay, and outside the electrostatic field is independent of R. It's proportional R is for 0 when small r is greater than d. We'll be doing examples on this conducting slab. Okay, and that example is copy pasted from the David Griffith. Okay, so then there's one more example. If, for example, there's an insulating slab, insulating or non-conducting slab. In case of insulating slab, the charge is given to it. The charge will reside in the meat as well as on the surface, so that the electrostatic field inside will be non-zero, and electrostatic field inside is proportional to R, directly proportional to R. When small r is less than d, we'll be doing this example. And outside electrostatic field is again independent of R when small r is greater than d. Okay, so there is a sequence. That's why I have written all this. Okay, so number one is that there's a possibility. एक तो इस पर directly question आ सकता है in the examination. Number one, there's a possibility. Number one. Number second is that the graph can be, if for example you are supposed to plot the graph, then from this data you can directly plot the graph without doing the example. And number third is that, for example, suppose that you are supposed to calculate the electrostatic field due to any of this charge configuration, like due to the insulating slab, or for example a solid cylinder, or for example a hollow sphere, etc. Okay, so then what you can do is this: you you can first of all see the 4 different options. Okay, now for example, suppose that you are supposed to calculate the electrostatic field due to the insulating slab. Now you know that the electrostatic field due to the insulating slab inside is directly proportional R and outside is independent of R. Then accordingly you can make an educated guess what the answer can be out of the 4 options. ठीक है ना बेटा, तो वहां भी आपको ये जरूरत लग सकता है. Okay, so that's why this is important. Number 1 is that a direct question can be asked. Number 2, graphical question can be asked on this data. And number 3 is that you can make an educated guess out of the 4 options which can be the right answer. Okay, so perfect. Okay, so we are yet to do this one that's infinite sheet, conducting slab and insulating slab. Okay, so I am sure ये example आपको अच्छी तरह से समझ में आई होगी. Electric field due to the solid. Okay, this was home assignment for you ना बेटा. तो यहाँ तक ये कुछ important points यहाँ पे थे. Okay, so these are some important points. Okay, point charge follow से solid से then solid sector non-uniform, like the solid sector non-uniform again, then the line charge and then the charged sheet. Okay, infinite sheet. Fine. Okay, then we have done this example. So here we are. Here we are. Now the infinite charged sheet. Okay, we have to calculate the electrostatic field due to the infinite charged sheet, and it is done on the David J. Griffith as well. Okay, so we'll be doing here it as well. Okay, so for example, here we have this an infinite large sheet, like this it is. This an infinite large sheet. Like this it is. Okay, now it is uniformly charged. Wait a moment. So it is uniformly charged like this. Okay, like this it is. Fine. So it's uniformly charged like this it is. Uniformly charged. Now we are supposed to calculate electrostatic field. Okay, so first of all, step down first is that identify the symmetry. It is symmetry. It has a plane symmetry. What we mean by plane symmetry? Like, let's for example imagine a hypothetical plane which is parallel to this sheet. A plane that is parallel to the sheet. Then there are infinitely many number of pointers on the sheet. Electrostatic field on every point of that sheet will be same. So we say that the electrostatic field due to this is what it has a plane symmetry. Okay, fine. Now here the Gaussian surface. Chosen Gaussian surface is what we call as Gaussian pillbox. That's called as Gaussian pillbox or simply a Gaussian cylinder like this. This is also called as Gaussian pillbox. Like this it is. So it's like this. This is a Gaussian pillbox which is penetrating right through the sheet. Fine. Okay, so this is the Gaussian pillbox which is penetrating right through the sheet. Fine. Okay, great. Now this is here the area of the cap. For example, it's equal to A, and this is the area of this end cap. It's also equal to A. Now you see the direction of the electrostatic field. Obviously, electrostatic field will be in this direction. This दिशा में electrostatic field होगा, and this area vector will be also in the same direction. Okay, so that means the angle here that's equal to 0 degree, or electrostatic field at this point is in this direction. Okay, away from the sheet, and the area vector is also in the same direction. So what is the angle here as well? That's equal to 0 degree. ठीक है ना बेटा? Now the flux through the lateral surface area here will be equal to 0. यहाँ से flux 0 होगा. Okay, why? The reason is this: area vector will be along this direction. For example, that area element here, this is dA. So along this direction it is, but the electrostatic field is along this direction. So what is the angle? The angle is 90, and cos 90, you know that's equal to 0 degree. Or more, what you can say is this: the electric field lines are coming out of the sheet and they're penetrating through these end caps, but the electric field lines will not penetrate through the lateral surface area. Then the flux through the lateral surface area will be simply equal to 0. Okay, so let's calculate this now. What is the flux and hence the electrostatic field due to this? अच्छी तरह से यहाँ ध्यान रखना बेटा. What's given is this: it's charge density sigma. Okay, so let's do it. Let's work it out. Okay, so ध्यान रखो बेटा. So here I will use the Gauss law. So let me use here the Gauss law. Gauss law is like this: integration of E dot dA is equal to Q enclosed by epsilon naught. That's equal to Q enclosed by epsilon naught. Okay, now what is the flux through this? So number 1, through its end cap, the flux is equal to E multiplied by A. So here I will write down E multiplied by A. Then plus flux through the lateral surface area will be equal to 0. Then flux through the another end cap is also equal to E multiplied by A. Cos 0 degree, that's equal to 1. So that will be in turn equal to Q enclosed. Okay, now what is the charge enclosed by this? The charge enclosed is this amount. This is the charge that's enclosed. This is Q will be equal to, sorry, we have to calculate the value of Q. So Q will be how much? Q will be equal to sigma multiplied by A. So the charge here enclosed Q, that will be equal to sigma multiplied by A. Sigma charge density. So Q will be equal to sigma multiplied, because this is the amount of the charge that's enclosed, and the electrostatic field will be contributed by only this, or the flux will be contributed by only this charge. Okay, so here I am writing E multiplied by A plus 0 plus E multiplied by A, and the charge enclosed is simply equal to what? That's equal to Q multiplied by, sigma multiplied by A. So here I will write down sigma multiplied by A divided by epsilon naught. Okay, then this here 2 times E multiplied by A is equal to sigma A divided by epsilon naught. A will cancel with A, so electrostatic field is simply equal to what? That's equal to sigma divided by 2 epsilon naught. Okay, so this is the electrostatic field, and in vector form you can write it like this and multiply here n cap, while n cap is a unit vector that is perpendicular to the surface, normal to the surface. ठीक है ना बेटा? It is sigma divided by 2 epsilon naught. Moreover, suppose that the distance here, the length of this Gaussian cylinder is called r here and r here as well. Now it does not depend upon the r. So this implies that the electrostatic field is proportional to r is power 0, or it means that it is independent of r. And in case you want to plot the graph of E versus r, that graph of E versus r will be simply what? It will be a straight line horizontal like this. It will be okay. So this is a E versus r graph, which is simply a straight line horizontal, and the electrostatic field here that will be equal to sigma divided by 2 epsilon naught. Okay, and this problem is also solved on the table diagram. You can check out table diagram. It is solved there as well. Okay, with a bit of this terminology is a bit different. Okay, so you don't bother about that. So we have calculated the electrostatic field of the sheet, isn't it? Okay, next up dekh lo beta. So we'll do a couple of examples here. A question has been asked in the JAS 2014 on this. Okay, we'll be doing that example as well. And then number 1, and then accordingly you can calculate it. Okay, so there are 4 infinite conducting plates. There are 4 infinite conducting plates like this is. Here it is 1 plate, here it is another plate, here it is another plate, and here it is another plate. Fine. So there are 4 conducting plates. Okay. Now the charge distribution is given to you. Charge density of this is plus sigma. Charge density of this sheet is equal to minus sigma. Charge density of this is plus sigma. Charge density of this is minus sigma. Fine. And then there are 4 different regions. Okay, rather 5 different regions. Okay, so like this it is. The diagram is like this. Along this direction there's x-axis, and then there are 4 different regions like this: first, second, third, fourth, and fifth. First, second, third, fourth, and fifth. Fine. And the question is like this: calculate the electrostatic field in these regions. That's region first, region second, region third, region fourth, and region fifth. Take na beta. Again, what you'll do is this: you'll use the superposition principle. We'll use superposition principle. What we mean by superposition principle implies that you will calculate electrostatic field due to one sheet, then calculate electrostatic field due to another sheet, and so on, and then take the summation. Okay, accordingly take the summation. Okay, taking care of the directions as well. And what you know is this: electrostatic field. Simply what you know is this: electrostatic field. So electrostatic field due to a positive sheet is equal to sigma by 2 epsilon naught away from the sheet. And so it's like this. For example, here we have a positively charged sheet. So electrostatic field at this point will be in this direction, and electrostatic field at this point will be in this direction. That will be away from it. Fine. And if there's a negatively charged sheet like this, so this is a sheet which is negatively charged, then electrostatic field due to negatively charged will be obviously towards the sheet. Will be simply towards the sheet like this, and its magnitude is simply equal to sigma divided by 2 epsilon naught. Because of this sigma divided by 2 epsilon naught. Okay, so let's calculate what's the electrostatic field here. So let's calculate, for example, there is this point. Suppose this point is point P. So let's calculate electrostatic field at point P. So what I will write down is this EP. Okay, EP is the electrostatic field at the point P. So at point P, there will be how many electric fields? There will be electric field because of this plus sigma, minus sigma, plus sigma, minus sigma. Because of plus sigma, the electrostatic field will be towards left. Because of minus sigma, electrostatic field will be towards right. Moreover, the magnitude will be same because the electric field at the point P is independent of the distance. So it means that electrostatic field at the point P is same because of plus sigma and same because of minus sigma as well. Okay, magnitude wise, but in direction wise they will be opposite. So electrostatic field at point P because of plus sigma will be towards left, because of minus sigma will be towards right. So these two will cancel. Then because of this plus sigma, electrostatic field will be again towards left, and then because of minus sigma towards right, and again the two will cancel. So that means the net field at the point P will be simply equal to 0. Yes, समझ में आया बेटा? Electrostatic field at the point P will be equal to 0 because of plus sigma towards left, because of minus sigma towards right, because of plus sigma towards left, and because of minus sigma towards right. So the net field at the point P will be equal to 0. अब ध्यान रखो बेटा ये. So here we have this, for example, point Q. Okay. So electrostatic field at point P, Q, because of plus sigma will be in this direction. And because of minus sigma in the same direction. Repulsive because of this, attractive because of this. So these two will add. Then because of this plus sigma, it will be repulsive in this direction. Then because of this minus sigma in this direction. So because of this plus sigma, minus sigma, the field at the Q will cancel. So the net field at the point Q, the electrostatic field at the point Q, is simply equal to sigma by 2 epsilon 0 plus sigma by 2 epsilon 0. So that is simply equal to sigma by epsilon 0. And sigma by epsilon 0 along what direction? Along the x direction. So that means here I will write down electrostatic field at the point Q will be along the I km. So I can write like this, or along the x km. Sigma by epsilon naught multiplied by x km, or sigma by epsilon naught multiplied by I km. Okay, great. फिर से ध्यान रखो बेटा. Now next is that we are supposed to calculate electrostatic field at the point R. At point R, electrostatic field at point R, because of plus sigma will be towards left, isn't it? It will be towards right, repulsion. Then because of minus sigma, it will be towards left. So these two will cancel. Then because of this plus sigma, the electrostatic field will be repulsive, so it will be towards left. Then because of this minus sigma, it will be attractive, so towards right. So again, these two fields will cancel. So that means the net electrostatic field at the point R will be again equal to 0. फिर से ध्यान रखो बेटा. Because of plus sigma towards right, because of minus sigma towards left, because of this plus sigma now towards left, and because of this minus sigma towards right. So the field will be again equal to 0. Okay, so here I will write down the electrostatic field at the point R will be again equal to 0. Then you are supposed to calculate what? Electrostatic field at the point S. Okay, so suppose that here we have point S. At the point S, we want to calculate electrostatic field. Because of plus sigma towards left, because of plus sigma towards right, because of minus sigma towards left. Then because of this plus sigma, so field because of this and this will cancel. Because of plus sigma towards right, because of minus sigma towards left. Because of this plus sigma, it will be in this direction. So these two fields will add. Because of this plus sigma, it will be towards right, and because of this minus sigma, it will be towards right. So the electrostatic field at the point S will be again equal to how much? That will be equal to sigma by epsilon naught, and again multiplied by I k. Okay. Now there is last point. Suppose here we have the one more point, and that point is T. So what is the electrostatic field at the point T? It will be because of plus sigma towards right, because of minus sigma towards left, because of plus sigma towards right, because of minus sigma towards left. The field at the point T will be again equal to 0. So here field at the point T will be equal to 0. Okay. Then accordingly, you can say that the electrostatic field in the region number first is 0. In the region number second, it is sigma by epsilon naught I cap. In the region number third, it is 0. In the region number fourth, it is sigma by epsilon naught I cap. In the region number fifth, electrostatic field is again equal to 0. Okay. So I'm sure ये example आपको अच्छी तरह से समझ में आई होगी. Okay. Then there's one more example, and that example has been asked in the just 2014. And we see that example that is ridiculously easy. Okay. तो आप ध्यान रखो बेटा. So that example is simply like this. That there are two large non-conducting sheets. Okay. So here I will give a home assignment for you. This will stay as a home assignment for you, and I'm sure you will be able to do this. Example is like this. For example, here we have this here one sheet, second, third, and fourth. Okay. Then again, there are how many regions? There's this region number first, region number second, then region number third, then region number 4, and region number 5. And you are supposed to calculate electrostatic field in all the 5 regions. Charadian step, this is plus sigma. Charadian step, this is plus sigma. Charadian step, this is minus sigma. Charadian step, this is plus sigma. So you'll have to calculate electrostatic field in the region number first, second. So calculate electric field in region first up to 5th is equal to what? Okay. So this will stay the home assignment for you. I'm sure you must be able to do it. Ab dekh lo beta ye example. Okay. So let's do this example. Two large non-conducting sheets are there having charge densities. So charge density of one sheet is given and charge density of another sheet is also given. What is the electric field between the sheets? So you'll have to calculate what is the electrostatic field between the sheets. Okay. But one sheet is positively charged, another is negatively charged. So this sheet is negatively charged here. I'm writing here minus. Okay. So then you will have to calculate what electric field between the sheets. Okay. So first of all, let's make a diagram. So पहले diagram बना देते हैं. Okay. So let's first of all make a diagram. Yeah. Okay, so let's first of all make a diagram. Diagram is simply like this. Here we have this one sheet and here we have another sheet. One is positively charged, this is plus sigma 1, and it says minus sigma 1 charge density. And then you will have to calculate what electrostatic field in between the sheets. Okay, so that in electrostatic field at this very point you are supposed to calculate it. Now field will be in this direction, because electrostatic field because of this positive sheet will be towards right, and because of this minus sigma it will be towards right. So the two fields will simply add. So this is the net electrostatic field. So here I will write down the net electrostatic field, that will be simply equal to E1 plus E2. E1 plus E2. And what's the magnitude of electrostatic field because of the sheet number 1? That's equal to sigma 1 epsilon 0, and because of this, this is sigma 2. So because of this it will be equal to sigma 2 divided by epsilon naught divided by 2 epsilon naught. So it will be simply sigma 1 plus sigma 2 divided by 2 epsilon naught, like this, isn't it? Now sigma 1 and sigma 2 is given to you, and safely you can do it yourself. Sigma 1 and sigma 2, how much is that? Simply I will substitute the magnitude only. Okay, I will field E will be equal to sigma 1 plus sigma 2 divided by 2 epsilon naught. Okay, so what I will do is this, sigma 1 and sigma 2, what's that? Sigma 1 equal to 6.8 plus 4, here plus 4, they are micro points. Then here I will write by this epsilon naught is 8.85 10 to the minus 12, but it's 9 into 10 to the minus 12. Okay, then here it's Newton per Coulomb. Newton per Coulomb. So the electrostatic field E will be equal to 6.8 plus 4. That's I think this is 8 plus 10. 10, so 10 is